Good morning, student. So, in the last lecture, we have seen the superposition of the wave and interference. Okay. So, let us recall what's the interference. When two or more waves having the same frequency and same amplitude, when superimpose, then the physical effect can be seen on the screen. That is known as interference. So let us see the interference for water waves. Here in this diagram, you can see the two sources, see S1 and S2. Okay, these are the two sources, okay, in the water, and they are sending the waves. They are having the same frequency and same amplitude. Okay, so here you can see a straight curves. These straight curves are crest, and while the dotted curves are trough. Okay, so both these sources are sending alternate crest and trough. Okay, and they are superimposed with each other. Then their resultant, you can see here the resultant of them, where they interfere with each other, intersect with each other. Okay, so that intersecting point will give us a resultant displacement, okay, or resultant amplitude of the two waves. So here you can see the red spots, red dots are given, and these red dots indicate that, if you will see, the red dots are on the intersection point of trough and the crest due to both. Okay, see, the crest due to one wave is superimposing the trough due to another wave. So here this intersection point is denoted by a red spot, while the blue spot, if you will see, the trough due to one and trough due to another. Again, crest due to one and crest due to another. Okay, so having the same phase, they are interfering. It is denoted by the blue spot. Okay, so the lines, you can see this radial distance. One, if you will join these points, you will get a ray, which is one is red spot and one is having blue spot. Okay, so the red is one which is out of phase, and blue is one which are in phase. Okay, so when the two waves are in phase, means having crest or trough coincident, then the displacement is maximum. Okay, and we call, it will show you the maximum amplitude, and amplitude, square of amplitude is proportional to intensity. So if there is a maximum amplitude, means the intensity will be more, maximum. And the red spot tells you that the minimum intensity, means minimum amplitude. Okay, so here minimum intensity. Okay, so in this way, this is the interference pattern in case of water waves. So the same nature can be observed in case of light also. So the Young was the first scientist who has observed that the light waves light can also show this interference pattern, and that's why it is clear from this experiment that light shows the wave nature. So let us see what's the Young experiment. Okay, so today we'll see only the experiment. See how the Young double slit experiment. See here the diagram, Young's double slit experiment. This is our experimental arrangement. Okay, so here you can see that one source S, then one convex lens is there in front of that source. Then you can see in front of convex lens there are two slits, S1 and S2. And in front of that PQ is your screen. Okay. So this is S is your main source of light, which is sending the light waves. Okay. Now why this convex lens is kept in front of this source? So convex lens will help us to get the parallel rays of light. Okay. So due to this convex lens, we'll get the parallel plane wavefront of the light. When this wavefront will incident on the slits S1 and S2. Here AB, on this AB you can see the slit S1 and S2. Why we need these two slits? See, because from the first source, okay, when the light coming from the first floor will enter through S1 and S2, this S1 and S2 will start behaving like the secondary source of light. Okay, and see, this two source will be a coherent source. So what do you mean by coherent source of light? So coherent source means though these two are having the light coming from these two sources is having the same frequency, okay, and having the same phase. They are in the same phase, originating from the same phase. And one more, or you may say the phase difference between these two waves is same. So we'll get a clear interference pattern. Okay. So directly if you will take the two source of light, then you will not get the clear interference pattern. Okay. So instead of taking the two different source, here two source are two coherent sources S1 and S2 are obtained from a single source of light S. Okay, as this source, the light rays are coming from the same source S. Both will have the same frequency and same phase difference, or they will be in the phase always. So we'll get the two coherent sources. That's why the S1 and S2 are the slits made here. Okay. So this, due to this slit S1 and S2, we'll get the two sources of light, two coherent sources of light, and they will send the light waves, and these waves will superimpose in phase. Okay, the waves coming from these two sources will superimpose in phase as they are coming or coming out as in phase. Okay, so here you can see the interference pattern of light. Okay, when the crest due to one wave coincide with the crest due to another wave, the displacement will be maximum. And when crest due to one wave coincide with trough due to another wave, then the intensity will be minimum. Okay, so maximum displacement means maximum amplitude, and maximum amplitude means the intensity will be maximum, and the amplitude means intensity will be minimum. So when there is a minimum intensity means exactly it will become zero as both are having the same amplitude. Okay, so when the intensity is 0, we'll get the dark band, and when the intensity is the maximum, we'll get the bright band on the screen PQ. So you can see here the alternate bands of minimum, maximum, minimum, maximum, minimum, maximum you will get. That is dark and bright bands. And these dark and bright bands, this pattern is known as interference of light. Okay, and we call this experiment as Young's double slit experiment. Okay, so due to double slit, the Young here will get the two coherent sources. So when what will be the intensity, how much will be the intensity, and what will be the frequency, that we'll study mathematically in the next lecture. Now this width of these bands, okay, dark band, bright band, this width is known as the frequency, the width is known as fringes of the band. Okay, so the remaining mathematical part we'll see in the next lecture. Okay, so till here at least experimental arrangement of this Young's double slit experiment you might have understood. So before we take this lecture of the mathematical lecture, you go through that from the textbook. Okay, bye, thank you.